Oh boy, am I excited to do another day of linear algebra. I actually have been looking forward to this, like, more than most. I feel like 25 minutes a day is so little to actually make progress, so am left wanting more. Anyway, today's game plan. The game plan for today is to check Anki first and foremost, as always. Make sure we stay up to date on our flashcards. So here we go. Oh, we got a nice nose shot there. Just made that up on guitar. I got that in my head. No Anki cards today. But I will be needing this computer actually to check my answers. Some of them on Quizlet. All right. So we answered like 13 or something questions yesterday. Let's go ahead and start checking them. When I'm done checking my answers from yesterday, I'll be back in a sec. All right, guys, I missed a few. What did I miss? Let's go through them. Okay, this one. It was asking for. It gives me this matrix with k as an unknown. It says what values of k is the system consistent. I solved for 2 because it'd be infinitely many if k equals 2, but then I didn't actually check if the other ones outside of 2 were inconsistent or consistent, meaning they would either be no solutions or solutions they actually would be solutions, so I didn't check the full answer, so it would have been all values of k. 13. This one was a simple like arithmetic problem, error. I just forgot to distribute this divided by -9 to the +1. I carried the +1 down instead of -1/8. That's a simple algebraic error, but I got the concept right essentially. And then I missed one other one. This one actually was like pretty good error to catch. So I wrote it in this form, but I actually put 2 subscripts on all the x's when that would not be correct. These should all be the same x. Oh, actually, I circled the wrong thing. These should all be x1s. These should all be x2s. These should all be x3s, not like x1, 3, x2, 3, x3, 3. That would be different variables. They're actually the same variables. All right. Good error catches. I'm going to do... Basically, I'm just going to do one more problem, and then we're going to start the next section. So we're going to actually... I have this note for myself at the beginning of Gaussian elimination that says, watch how to read and do proofs, see preface, but I just want to get into the next section, so I might push that off. We haven't worked with proofs yet, so maybe as soon as I see proofs, then I'll go ahead and do that. So let's finish up 26, and then I'll be back. All right, that's the last problem done. Took about 5 minutes, so I think I got the answer right, but the explanation part is a little rough, but that's it for section 1.1, Introduction to Linear Systems, I believe. Lots of pages of practice problems. Wow. Didn't realize it accumulated that quickly. There's actually more in the book too, surprisingly. All right, we got questions here to answer. What are augmented matrices? Matrices that represent linear systems, at least in this case. I don't know if there's surely augmented matrices might be a broader term. That's not just about linear system, but it's representing some kind of something else. I'm going to call them systems of equations right now. All right, what are elementary row operations? These are ways to algebraically manipulate matrices to find solutions without changing solution set. All right, I think that's fine. Okay. Good enough for now. Let's get into section 1.2, Gaussian elimination here. And I believe this is going to be a section on how to solve complex matrices or larger matrices. So the first section, 1.1, Introduction to Linear Systems, we had 3 sections: linear equation, linear systems, and 2 and 3 unknowns, and then augmented matrices and elementary operations. So this one, let's go ahead and just write down the sections we're going to be seeing in this new section. Okay, here we go. Considerations in solving linear systems. Echelon form. Echelon form. Elimination methods. Gauss-Jordan. Gosh, I learned that somewhere. Gauss-Jordan. Some memory. Homogeneous or homogeneous, one or the other. Homogeneous linear systems. This is a fatter section. Free variables in homogeneous linear systems. Dang it, we're about to run out of time. 30 more seconds. Dang it. All right, I guess we're just gonna have to finish out writing these stuffs down. Okay, Gaussian elimination and back substitution. Some facts about echelon form. This section, man, so long about echelon forms. There we go. Oh, round off error and instability. There we go. So there's 8 sections to this section. 8 subsections of this section. Gauss-Jordan, man. Learn about that fucker sometime. Long time ago. Maybe pre-algebra in high school. No, pre-calculus, I mean. Okay, next is matrices and matrix operations. That's the next section after this. So here we are in a Gaussian elimination. Excited to continue moving. We could go slower through this book, but I'm a proponent of moving forward and relieving practice more, not trying to master every single thing one by one and then move to the next thing. Rather, get a general idea, move on, come back, improve it, recall it from memory, retrieve, keep moving, etc. So there it is. Another day of linear algebra. We're done doing section 1.1 practice problems for now. We'll come back and do more in the future. I would say give it about a week, or by the time, whichever comes first, a week or at the end of reading 1.2 Gaussian elimination. So that was Introduction to Linear Systems, section 1.1. Yeah, talk to you guys later. See ya.